Yes, students, good morning to all of you, Nana. So here I'm going to share your document, objective material. Yes. So which question we are solving, Nana? Yes, this is the sheet we are solving. And I hope question number 56 is over now. No? For extra diffraction, order of size of the obstacle is what? 1 angstrom, you know, okay? And 57 is also over. Voltage applied across the X-ray tube is 1000 volt have given, okay? Yeah. And 58, see? Question number 58, Nana? 58, question number 58. See there. Which of the following is the wavelength of X-ray? Question number 58. Wavelength of X-rays is of the order of angstrom. So 1 angstrom. Next, lattice constant. I hope this 58, 59 also over, Nana, no? Yes, it is over. So this answer is 3 into the power of 8 we got. This is also over, Nana. Okay? Yes. Now let us go for question number 250, 60. Yes, students, see question number 60, Nana. Uh-huh. 16. The lambda minimum for X-rays depends upon, okay, minimum wavelength for X-ray depends on what factor? On what factor lambda minimum depends? See, it depends minimum wavelength. See, lambda is equal to Hc upon energy. This is energy is nothing but energy of electron. So here target element will be there. Okay, students, now is it visible? Students, is it visible screen now? Yes, okay, good. Now, so what we are solving? Lambda minimum for X-ray depends upon. See here, one target element is there, and this target element of higher atomic number Z, when electron, fast moving electron, velocity is very large. When it hits this target, X-rays will produce. Okay. So the wavelength of this X-rays depends upon energy with which these electrons are hitting this target element. Okay. So energy of electron. Option 2 is right answer. Not on the atomic number of a target. It does not depend upon the atomic number of a target. It depends only on the energy of electron alone. Okay. Next. The order of energy of X-ray photon is, so energy of X-rays will be in terms of kilo electron volts. You need to remember this. It is not only electron volt. It is in the order of thousands of electron volts. So kilo electron volt is right answer. Next, in vacuum tube, sorry, if vacuum tube is operated at 6.4 kilovolt, what is the wavelength of X-ray produced? Okay, so energy given Anna 6.4 kilovolts is nothing but 6400 volt. Okay, so we know lambda is equal to 12,400 upon energy, that is 6,400. If you do these calculations, you will get 124 upon 64. So you will get the answer. Okay, so it comes out to be 1.93 angstrom. 124 by 64 value 1.93. No? Yes. So 1.93 is the right answer. Okay, do these calculations, Nana, you will get the answer. Okay, so this is the formula, Nana. So this formula so many times we are using, you need to remember. So if you want lambda in angstrom, the formula is 12,400 in electron volt by energy. Whatever the energy they will get. If you want wavelength in nanometers, then it will be 12,1240 only. Only 1240 will be there. Got it? Okay. Yes. So many times I am repeating that point. You need to remember. Okay, na? Next. Question number 63. Question number 63. What is that question? See. Question number 63. What they have given. When electron is incident on molybdenum, then by changing the energy of electron. So if you change the energy of electron, lambda minimum changes. Just now we have discussed that minimum wavelength of X-ray depends upon the energy of electron. If you change the energy of electron, lambda minimum also changes. Whatever may be this target element, if you change the energy of electron, the minimum wavelength also changes. Okay, minimum wavelength remains constant, wrong. K alpha, K beta lines changes, wrong. K alpha, K beta lines depends upon this molybdenum, this material, what material we are using. Okay, so this is also wrong. So option 1 is the right answer. Remember, Nana. Clear? Yes. Next question number 64. See, in Coolidge tube, the relation between usage voltage V and minimum wavelength lambda. So just now I given minimum wavelength lambda minimum is equal to Hc by electron volt. Okay, what is the relation between these two? H is constant, C is constant, electron E is constant. So lambda minimum is inversely proportional to V potential. Yes, this is the relation. Correct? Yeah, where it is? Yes, here it is. Option 4 is right answer. Got it, students? Okay. Next. Question number 65. See here, question number 65, they have given that in an X-ray tube, accelerating potential is 60 kilovolt, 60,000 volt, which is what is the maximum frequency of emitted X-rays? Okay. We know energy E is equal to h nu or hf, then F is equal to what, Nana? Energy upon H. Okay, energy given how much? 60 kilovolt. Okay, I'll write 60 kilo 10 to the power of 3 volt upon H value what is 6.63 into 10 to the power of minus 34 joule second. See, this is the voltage here joule, so they won't cancel. So that's why this energy we should write in terms of electron volt. That means this is not your energy, this is the voltage. Energy is nothing but EV. So 60 kilo electron volt is the energy. That is nothing but energy is equal to 60 kilo electron volt is 1.6 into 10 to the power of minus 19 joules. Yes, this is the energy. So blindly don't do this type of mistakes. Okay. Yeah. Now divide this equation with this. You will get frequency is equal to energy by H. That is nothing but 60 into 10 to the power of 3 into 1.6 into 10 to the power of minus 19 upon H. 6.63 into 10 to the power of minus 34. Here joules, here joule second. Joule cancel, we will get 1 by second. Yes, 1 by second is the unit of frequency. Yes, perfect unit also. Now if you do these all calculations, you will get value as 1.45 into 10 to the power of 19 H. Yes, you need to do these calculations now. Okay, you need to be perfect, fast. Speed and perfection is important if you want to solve this type of questions. Okay, clear? Yes. Let me see what are the students present today. Okay. 65 is over. Next question number 66. Yeah, here is your question. What is the wavelength of least energetic photon emitted in Lyman series of hydrogen atom? Yes, see, Lyman series. What is Lyman series? When electron jump from any one of the air energy level to n is equal to 1, then spectral energy radiation emits lies in Lyman series. Okay, and the wavelength of emitted radiation is 1 by lambda is equal to R into 1 by n final square minus 1 by n initial square. No? Yes, this is the formula. Do you remember these formulas? Yes. Now here, what is R, sir? R is Rydberg constant, its value is 1.1 into 10 to the power of 7 per meter. Per meter is the unit. Meter per 1 by meter is the unit. Okay. Yeah. See what they're asking. What is the wavelength of least energetic photon? Energy should be least means wavelength should be maximum. See, we know energy is equal to hc by lambda. If lambda to be least, sorry, energy to be least means wavelength should be maximum. Are you understanding? Yes, that means maximum wavelength we need to find. Okay. So Lyman series they are asking. Lyman series means finally it has to come to n final should be equal to 1. Then only it is called as Lyman series. Okay. Yes. And least energetic means this lambda should be maximum. If this lambda should be maximum means this n initial should be equal to second energy level. Means 1 by lambda is equal to 1.1 into 10 to the power of 7 into 1 by 1 square minus 1 by 2 square. That's it. Means 1 by lambda is equal to 1.1 into 10 to the power of 7 into 1 minus 1 by 4. Means it is 3 by 4, no? Yes. 1 by lambda is equal to 1.1 into 10 to the power of 7 into 1 minus 1 by 4 is 3 by 4. Yes. Then what you want? Lambda you want. Lambda is equal to 4 by 3 into 1.1 into 10 to the power of 7. You will get unit is meter. So if you do these calculations, you will get the answer lambda is equal to 122 nanometers exactly. Means option 2 is right answer. Are you understanding, students? Calculations needs to be perfect. What they're asking question Lyman series. So n final should be equal to 1. And because they are saying that least energetic, energy should be least means wavelength should be maximum. Wavelength should be maximum means this energy level difference should be small. Means initially it has to come from n is equal to 2. N is equal to 2 it has to come. So substitute 2, do the calculations, you will get the answer. Hope you understand this question. I hope you understand this question. Okay. Yeah. Question number 67C. What is the ratio of shortest wavelength of Balmer series to shortest wavelength of Lyman series? Important question. They may ask you this type of questions repeatedly. They may ask. They are asking also. Okay. Okay. So what is the ratio of shortest wavelength? We know just now we have calculated that 1 by lambda is equal to Rydberg constant into 1 by n final square minus 1 by n initial square. They are saying that shortest wavelength, for shortest wavelength, n initial should be infinity now. Then only wavelength will be short, it's very small. Because lambda should be less means this value should be more. That's it. Okay. Yeah. Now first Balmer. So it depends upon n final. Okay. Yeah. So 1 by lambda is equal to r by n final square. We can write this is 0. However, 1 by infinity is 0. Okay. Yeah. Now Balmer series to shortest wavelength of Balmer series to Lyman series. Okay. Balmer series. Balmer means n final should be equal to 2. Lyman series is nothing but final stage should be equal to n is equal to 1. The electron has to come to n is equal to 1. Then it is called as Lyman series. No? Yes, substitute there. So 1 by lambda of Balmer upon 1 by lambda of Lyman should be equal to r divided by, so directly we can write this equation. We can write lambda is proportional to n final square. No, yes, r is constant. However, yes, lambda is proportional to n final square. Okay. Yes. So I want wavelength of Balmer to wavelength of Lyman. Okay. So lambda of b upon lambda of L we want means Balmer series n is equal to 2. So 2 square by Lyman series n is equal to 1 square. 2 square is 4, 4 by 1. So its ratio is 4:1. Yes, where is the option? Yes, first option only is there. 4:1. Got it, students? Important, this type of questions they are asking regularly. Okay, in chemistry also they will ask, need to be remember this type of questions. Okay, and they for your CBSE examination also they will ask CBSE students, remember. Okay, next question number 68. The kinetic energy of hydrogen atom of first Bohr's orbit. What is kinetic energy? Kinetic energy is nothing but negative of total energy. Correct? Yes. We know total energy of Bohr's hydrogen atom is minus 13.6 electron volt. Then kinetic energy how much Nana? Kinetic energy is minus 13.6 electron volt. So it will be plus 13.6 electron volt. Yes. Plus 13.6 where? Option 2. No? Do you remember that relation between kinetic energy, potential energy and total energy? It is in the ratio of 1:2 minus 1 by 2 is to minus 1. Do you remember these relations? You need to remember, Nana. Very important. Okay. Next. Question number 68 is over 69. According to Bohr's model of hydrogen atom, energy is proportional to, yes, energy is equal to minus 13.6, yeah, minus 13.6 Z square by N square, no, electron volt. Means this is constant. It depends upon proportional to Z square by N square. Yes, energy is proportional to Z square by N square. Where it is? Z square by N square. Where? Z square by N square. Yes, minus, because here minus is there. No, yes, minus. Proportional to minus Z square by N square. Okay. Option 3 is right answer. Got it, Nana? Yes. In the above question, radius is related to. So, do you know radius of Bohr's atomic model can be written as R naught, some constant value 0.58. Okay, that value into N square by Z. Means radius is proportional to N square by Z. Yes, where it is? N square by Z. Option 1. Okay, remember Nana, these are very important points. How energy related to atomic number and principal quantum number, and how radius is related to atomic number and principal quantum number. Okay, next question number 71. If the ionization potential of hydrogen atom is, so ionization potential IP of hydrogen atom is 13.6 volt they have given. Okay, fine. What is the ionization potential of helium atom? Helium. This is for hydrogen. Then what is for helium? Helium atomic number what na? Helium. Helium atomic number is Z is equal to 2. No? Yes, we know energy is equal to 13.6 by Z square. No? Yes. So means nothing but 13.6 divided by 2 square. Z is equal to 2. No? Yes. 13.6 by 2 square is 4. Clear? Sorry. You know, energy is equal to 13.6 Z square by N square, no? Yes. So they are not saying anything about N. So it is directly proportional to Z square. Means 13.6 into 2 square. Means 13.6 into 2 square is 4. So calculate it. What you will get? 6 4s are 24. Okay, 4. 2. 3 4s are 12. 12 plus 2, 14. 1 will be there. 3 4 1s are 4. 4 plus 1, 5. Yes. 54.4. So it is around 54.2. Yes. Option 3 is there. Okay. Clear? Got it? Yes. Next. Question number 72. Let us go for question number 72. See what they have given. Question number 72, Nana. Which of the following statement is correct statement? They're asking. Okay. Lyman series is a continuous. No, wrong. Lyman series is not a continuous series. Okay. Next. Balmer series lies in ultraviolet region. Wrong. Paschen series lies in infrared. Yes. Balmer series lies in visible region, Nana. No? Yes. Bracket series lies in visible region, wrong. So correct statement is third option. Remember which series of lines present in which spectrum, in which region of the spectrum, important. So Lyman series lies in what? UV rays. Balmer series lies in visible, okay. Passion, bracket and fund, these all lies in IR, infrared region of spectrum. You need to remember these three very important points. Okay, option 3 is right answer. Next, 73. According to Bohr's theory of hydrogen atom, the speed of electron, its energy and radius of the orbit varies with the principal quantum number n respectively. Yes, in one question all the points. We know speed v is equal to 2.186 into 10 to the power of 6 z by n. This is the formula. Velocity radius r is equal to 0.58 into n square by z. This is the formula for radius. And energy is equal to minus 13.6 into z square by n square in electron volt. This is in meters, this is in angstroms, and this is in meter per second. Okay, so how first one they have given that a speed of an electron proportional to z by n, means speed is proportional to 1 by n. Next, radius, they are saying that energy is proportional to 1 by n square. Next, they are saying about radius. So radius is proportional to n square. Yes. So these all three will be perfectly fit in option 1. Are you remembering these all formulas? We have derived these equations also. Do you remember? In atoms chapter, we have derived these all equations done. Okay, you need to remember these all things. Okay, yeah. 73 is over. Next, question number 74C. If ionization potential of hydrogen atom is 13.6 electron volt, then its energy in n is equal to 3 is. What is the meaning of ionization potential? Ionization potential is nothing but energy required to remove an electron from its ground state. It is called as ionization potential, and the value is 13.6 electron volt. Okay. So then, what is the energy of the electron in the ground state? This minus 13.6 electron volt energy will be there for the electron in the ground state. Now, when n is equal to 3, what is the energy? You know, energy is equal to minus 13.6 electron volt upon n square. Okay, yes, minus 13.6 upon n square is 3 square, 9 it. 3 square is 9, no? Yes. So 13.6 by 9, what you will get? 13.6 by 9 is 1.51 electron volt with negative sign. Yes, this is the right answer. Minus 1.51 electron volt. Do these calculations. You have to divide 13.6 with 9. 9 cannot divide 13 only one time. 9 ones are 9. What will be the remaining 4? If you keep point 46. 9 5s are 45. 1 will be there. Because of this point 10. 9 ones are 9. Yes, 1. Means the value is 1.51 electron volt. Here minus is there. So that's why negative sign. Okay. Yeah. So 1.51 electron volt is the right answer. Clear? Yes. 74 is over. Next. 74 is over. Next question. Previous year questions na. See in that previous year questions, what they have given? The ground state energy of hydrogen atom is minus 13.6 electron volt. Ground state energy it is. Okay, fine. Energy of ground state energy is equal to minus 13.6 electron volt given. We know this value also. Okay, when its electron is in first excited state, then what is the excitation energy? See, when electron is in ground state and it has to go to first excited state, means n is equal to 2. So from here to here, if electron has to excite, how much energy is required? That energy is called as excitation energy. Okay. So here energy we know E1. Let us take here energy is E2. E1 value is given 13.6 electron volt. Then what is E2 value, Nana? We know E2 value. E2 is equal to minus 13.6 divided by n square electron volt. Because n is equal to 2, it will be minus 13.6 divided by 2 square is 4 electron volt. Clear? Yes. Then energy release here is E2 minus E1. So E2 value is minus 13.6 electron volt by 4 minus E1 is minus 13.6 electron volt with negative sign. Means it will be minus of minus, it will become plus. Plus 13.6 minus 13.6 by 4. All are in electron volt. Take 13.6 common, you will get 1 minus 1 by 4. 1 minus 1 by 4. 1 minus 1 by 4 is nothing but 3 by 4. So 13.6 into 3 by 4 you will get. Yes. 4 ones are 4, 4 3s are 12, 4 4s are 16. Yes. So 3.4 into 3. What you will get? 3 4s are 12, 1, 3 3s are 9, plus 1, 10. Yes. 10.2 electron volt. Yes. Option 1 is right answer. Are you getting, students, what I am doing there? What I have done? This energy minus this energy subtraction I have done. This energy subtraction only will release here. It is called as ionization energy, ionization excitation energy we can call that. Are you getting? Ionization excitation energy. Okay. So that only I have done. That is small calculations. So need to be perfect with the calculations. If you are a smart student, you will remember this. This is almost 10.2 electron volt always. This will be 3.4 electron volt. If you remember that energy level diagram, it will be very easy for you. See, energy level diagram one more time I am trying to show you. This is n is equal to 1. It is minus 13.6 electron volt. Here n is equal to 2. This is minus 3.4 electron volt. This is n is equal to 3. This will be minus 1.51 electron volt. This is n is equal to 4. This will be minus 0.34 electron volt. You will get almost. Okay, yeah. So this energy difference how much? This energy difference how much? This energy difference how much? Or this energy difference how much? You need to remember all this. Just by hand them, calculate and keep in mind. Very useful, so that you can give the answer in fraction of seconds if you remember these all values, energy level differences. And if you remember these all values, then also it will be useful for you. Very important points. You need to remember these all for fast calculations. Okay. Next, question number 2C. Question number 2. The ionization energy of electron in the hydrogen atom in its ground state is 13.6 electron volts. Same as it is like this. Okay. The atoms are excited to higher energy level to emit radiations of 6 wavelength. Total 6 different wavelength it is emitting. Okay. Then maximum wavelength of emitted radiation corresponding to the transition between. Yes, important point. How many number of wavelength of light are emitting? 6. We know number of different types of wavelength emitted formula is n into n minus 1 by 2. So this is equal to 6 given. Means n into n minus 1 is equal to 12. Multiply with 2 here. Okay. So it will become what, Anna? N into n minus 1 is equal to 12. Means what you will get? So definitely n should be 4. No? Yes, calculate. 4 into 4 minus 1 is equal to what? 4 into 3 is equal to 12. That means n should be equal to 4. Are you getting? Okay. So n value should be equal to 4. Now what they are saying? The maximum wavelength. See, the 4 energy levels are there. N is equal to 4, n is equal to 3, n is equal to 2, n is equal to 1. So 6 different. Here one will come, here one will come, from here one will come, from here one will come, from here one will come, like this. So we know wavelength should be maximum, means lambda maximum, lambda is equal to 12,400 hc by energy, we can say 12,400 upon energy we know. Means for lambda to be maximum, this energy level difference should be minimum. So energy level difference, see this diagram only we can say this is minimum for this transition. Means from n is equal to 4 to n is equal to 3, if electron will transit, then radiation emits will be maximum radiation. So this transition should take place from n is equal to 4 to n is equal to 3. This is clear cut concept. If it is there in your mind, then only you can answer, Nana. Otherwise it is difficult to answer. Students, you need to read all the things. Atomic structure total in chemistry you have studied in first year, and in second year also it is repeating. That means it is very important. This is the basic for modern physics. You need to remember points. Okay. Next, question number 3. Let us go to question number 3. Question number 3, Sinana, they have given that in Rutherford scattering experiment, when a projection of charge is Z1 and mass is M1 approaches a target of nucleus of Z2 charge and mass M2, then distance of closest approach R0 is R0. Then energy of a projectile is, see, when alpha particle is coming like this towards this, having a charge Z1 and mass M1, here one nucleus will be there, Nana. Yes, here nucleus will be there. So up to one particular distance it will come. After that it won't travel forward, because at this distance kinetic energy of this particle will be equal to potential energy, electrostatic potential energy here. Clear? Yes. So this kinetic energy is half m square. So kinetic energy I can write is equal to potential energy is what, Nana? Something K Q1 Q2 by R. Q1 Q2 by R. Correct? Yes. So this energy is proportional to what? Q1 and Q2. Means Q1 and Q2 they have given Z1 Z2. Yes. Proportional to Z1 and Z2 product. It is not proportional to masses. It is proportional to charges. So we can say directly proportional to Z1 Z2. Energy of a projectile, this projectile whatever it is going here, this energy of a projectile is proportional to product of their charges. Okay, proportional to Z1 Z2 we can say. Point is important, conceptual question you need to remember. Okay, next. Question number 4, see, the energy of hydrogen atom in ground state is minus 13.6 electron volt. Then energy of helium ion in the first excited state. Okay, we know energy is equal to minus 13.6 Z square by N square. They have given helium, Z value how much, Nana? 2, and N value how much? Because they are saying that. Yes, good, Naomi, very good. Because they are saying that first excited state means n is equal to 2. Substitute here, it will be minus 13.6, Z is 2. So 2 square by 2 square. This cancel. 2 square cancel. We'll get minus 13.6. Yes, minus 13.6 electron volt only. Are you understanding? Good, Naomi, very good. Okay, second option. Good. Okay, next. Question number 5. The wavelength of first line of Lyman series for hydrogen atom is equal to the second line of Balmer series for hydrogen-like atom. Then atomic number Z for hydrogen-like atom is what? Yeah. Question is important. Be careful. See here. We know that 1 by lambda is equal to R into 1 by n final square minus 1 by n initial square. No? Yes. When atomic number also mentioned, we have to write Z square. We have to write it. Remember this point. Okay? Yes. Now, what they are saying that the wavelength of first line of Lyman series. Okay, what is the first line of Lyman series? First line of Lyman series. Lyman series means, see here, yes, this is n is equal to 1, this is n is equal to 2, this is L, K, L like that, okay? So from n is equal to 2 to n is equal to 1, if a line comes, that is called as L alpha. That is called as first Lyman series. N is equal to 3 to n is equal to 2, if lines come, ray takes a transition. This will be called as Balmer series. Okay, Balmer series. Okay, yes. So first line of Lyman series I am writing 1 by lambda r is equal to, because they are saying that Lyman series for hydrogen atom n is z is equal to 1. So 1 square into r value, keep 1 by, finally it is coming to 1 square minus 1 by 2 square. Means 1 by lambda of Lyman series will become r into 1 minus 1 by 4. Correct? Yes. 1 by lambda of Lyman series is equal to r into 3 by 4. Then lambda of L is equal to what, Nana? 4 by 3r. Remember, this is equation number 1. 4 by 3r. Lyman L alpha, lambda of Lyman series is equal to 4 by 3r. Just remember this. Okay. And now I am going to Balmer line. Okay. Yes. So what they have given Balmer? No. Okay. So Balmer line they have given. Okay. So 1 by lambda is equal to what? Na? Z square into r into 1 by Balmer series. Balmer series means finally it should come to 2 square minus 1 by 3 square. Clear? Yes. So 1 by lambda of Balmer series is equal to z square r into 1 by 4 minus 1 by 9. Correct? Yes. So 1 by lambda of Balmer is equal to what? Z square into r into 9 fours are 36. I am calculating, cross multiply them. 9 minus 4. Correct? Yes. So 1 by lambda of Balmer is equal to z square into r into 9 minus 4 is how much? 9 minus 4 is 5. 5 by 36 we can write. Then lambda of Balmer how much? 36 by 5 or z square. Now according to the question that Lyman series is equal to second line of Balmer series, means this is equal to this, they are saying. Are you understanding? Yeah. So let us equate them. Let us equate them. What we will get, let us see. Means they are giving that lambda of Lyman is equal to lambda of Balmer. Okay. That is 4 by 3r should equal to 5 divided by 5r. Sorry. 36 divided by, no, sorry. Lambda beta, no, it is, yes. Lambda beta is 36 divided by 5r z square. Okay. R cancel. Z square is equal to 36 divided by 5 into, this will go that side, 3 upon 4. We can write. Correct? Yes. So calculate now. What you will get? 4 ones are 4. 4 nines are 36. No? Yes. 9 threes are 27. 27 by 5. Z square is equal to 27 by 5. Then what is Z value? Root of 27 by 5. So the value comes out to be 27 by 5. 5 5s are 25. 5. So around 2 point something you will get. That is option 4 is right answer. That is equal to 2. Remember. Okay. Option 4 is right answer. Comes out to be around 2 value, Nana. You will get the answer. So option 4 is right answer. Got it? Okay. Next. Question number 5 is over. Let us go for question number 6. Out of the following, which is not possible energy for photon to be emitted by hydrogen atom according to Bohr's model. 0.65, they are given 0.65, 1.9, 13.6. These are all the values, possible values. Only not possible values this. So this is the answer. This is wrong, this is wrong, this is wrong. This is the answer. Why is the reason is energy is equal to 13.6 by n square, no? Yes. If you keep n is equal to 1, you will get 13.6. Keep n is equal to 2, you will get 13.6 by 4. What you will get? Around 13.6 divided by 4. I will show you with calculations. 13.6 by 4, no? Yes. 13.6 divided by 4, it is 3.4, yes, 3.4. If you keep n equal to 3, you will get 13.6 divided by 9. So 13.6 divided by 9, how much? 1.51, 1.51. Next, n is equal to 4, keep 13.6 divided by 16. What you will get? See, 13.6 divided by 16 is 0.85, 0.85. Next, n is equal to 5, keep. You will get 13.6 divided by 25. 0.544. Okay. So among all these 11.1, where is that 11.1? Is it possible 11.1? So first one, if you divide with 2 only, you are going to take 3.4. You are not going to 11.1 energy level. Are you understanding? Then all the remaining values are lower than this 3.4 only. But this given odd number is there, that is 11.1. You are 11.1, you should get between these two only. However, between these two, n is equal to 1, 2. Only two available orbits are n is equal to 1 and n is equal to 2 only. Remaining any other orbit is not available here. Means this is the wrong. This is not a available energy for an electron in Bohr's theory. Did you got explanation, students? Okay. Yeah. So remaining questions we will continue in next class. And tomorrow you are coming to college, no? Yeah. In college we will discuss remaining problems. Okay. Okay. Advance Happy New Year to all of you. Bye.